Hi, my name is Connor, and this is the second installment of the videos for the new admins for Skynet. This topic is going to be covering networking within the cluster, and just some basic networking topics, and then how networking is done within the Skynet cluster itself. So, just to start very basically, so IP addresses, every device and virtual machine, anything that needs to communicate needs an IP address. It's like the address on your house. So if you want to send something to someone's house, you need to know their address. So IPv4 is the standard that we use at the moment. We're trying to move to IPv6, but IPv4 is the one that's used at the moment, so it's the one we're going to discuss. In IPv4, you have 4 tuples separated by dots. And then these are filled in with numbers between 0 and 255. So you can have any number between those numbers in them. And that's what makes up an IP address. Now, within that, there's lots of IP addresses that you can't use. There's different IP addresses that have different functions. And we also have access to certain IP addresses through HENET and stuff like that. So there are 2 main different types of IP addresses. There's public IP addresses and private IP addresses. Public IP addresses mean that if you type an IP address into your browser and it's a public address, you should be able to find that IP from anywhere in the world. Whereas a private address is an address that can't move across the public network. It can only move across a private network. So there are 4 main different networks that Skynet deals with. There's the Skynet public network, the Skynet private network, there's a network between the Ultron and Jarvis machines, and there's the UL network. So if we look at these addresses, some of them are public, some of them are private. Skynet public is a public address. Anyone can access these addresses from anywhere in the world. Skynet private is a set of private IP addresses. This is a set of private IP addresses as well. And this is a set of public IP addresses. The main way that you can tell the difference between a public and a private IP address are just the numbers that they use. I'm not going to go into this level of detail because you can look it up yourself if you want to know what the numbers are. So, and to start off, I'm just going to talk about the different ranges that we have and what they do and stuff. So, oh yeah, as well. We also have lots of different ways of writing down and denoting both IP addresses and the ranges of IP addresses that we want to specify. So I'm going to, it's important to know what the ranges are for different functions, and the machines need to know them as well in order to talk within the network. So if we take the first IP address, which is 193.1.99.64/26. This is one way of specifying what's called a subnet or a subnetwork, which is a group of IP addresses, and we've specified here what the range is. There are 3 main different ways of writing these down. I could also write it down as 193.1.99.64 and then 255.255.255.192. So you might be wondering where I got this from. So this is the first IP address in the network. That's what that IP address is. Then here we have a shortened version of this. So this is the longhand version of this. They're both called subnet masks. So the way that a subnet mask works is it tells you how many IP addresses are in that address. Most machines will want it in this format, but if you see it written down, you'll often see it like this. What this format means is it means how many ones have been specified in the binary form of this number. So if we write this number down in binary, which is 1, 2, 3, 4, 7, 8. So we have 8 there. Then 1, 2, 3, 4, 5, 6, 7, 8. 8 there. 1, 2, 3, 4, 5, 6, 7, 8. So there's 3 sets of 8 ones, because all of these IP addresses are split up into 4 sets of tuples, remember? So each tuple has 8 bits. And then the last tuple, we've got up as far as here, and we've 24 ones, so we need another 2 ones, and then 1, 2, 3, 4, 5, 6. 6 zeros. So basically all this is doing is telling you that there were 26 ones, and then there are 6 zeros. And that's just the way they split it up. And then to get this number, you just use your binary, you just use your standard binary to get it back. So if we add 128 and 164, we'll get 192, which is the last number in that subnet mask. So that's how you convert from this to this. Now you'll never really have to do that. It's just, it might come up in some of your modules actually, because we had to do that for one of our networking modules. And the other way of writing it is just 193.1.99.64 to 193.1.99.127. So all this is a range. This is the first IP address, this is the last IP address. So the IP addresses that Skynet has available to it are in a public fashion. So we've been lent these by HENET, are from this address to this address. So that you would think that means that we have 64 addresses that we can use, but we don't. So in every network, the first address is left empty. That's your network address. It denotes the network that you're on. And then the very last address is your broadcast address. So what a broadcast address is, if you want to send a message to every machine on the network, you send it to the broadcast IP address and it will broadcast it out to all of the IPs on the network. So you need to leave that one vacant as well. So that means we have, so here we started out with 64. We got dropped down to 62 IP addresses. Now, on top of that as well, an agreement we made with ITD was that we would leave them a certain number of IP addresses at the start of the network so that they could monitor and manage our network as well, because we have to adhere to ITD rules and Comnet's management of the network. So the IP addresses that were left for that were from 65 to 70. So our one actually starts at 193.1.99.71 to 193.1.99.126. So that leaves us with 56 IP addresses. So ComSoc has 56 public IP addresses that it can assign to public services that we want anyone to be able to access. So they're the IP addresses that we use for that. On the other networks we have the Skynet private. The range on this, I'm not going to do all this out again, I'll just tell you the range on it. 172.20.20.1 to 172.20.21.254. So that means that we have 510 private IP addresses in our network that we've set up. This is a network that was set up from the very start of Skynet. We can change that if we want to, because that's a public one, or that's a private network. So we can change that to whatever we want and add as many IP addresses to it as we want. That's just the way it's set up. We'll never have more than 510 private VMs, so we just don't need to change it. For the Jarvis Ultron network, the IP addresses that are available on that are 10.1.0.1 to 10.1.0.254. So there are 254 addresses available on that. Again, it's another private network. The only thing that is used for is a dedicated connection between Ultron and Jarvis, just because they need to be connected very reliably and securely. This network is way too big for this. This was just set up quickly when it was being done. Ideally, the network that you would set this up with, just to give you an example of how you go about designing a network, is you wouldn't want anyone else to be able to connect to this network if you know you only have 2 hosts. So if we wanted to redesign that network to make it more secure, we could set it up on 10.1.0.0/30. So that's or with the subnet mask 255.255.255.252. So Connor, why would you do that? So what I'm doing here is I've now set up a network that can only be used by 2 devices to communicate. So there can only be 2 devices connected to that network. So that means if anyone else tried to connect to that network, they wouldn't be able to, because there'd be no available IP addresses for them to talk to them. So what that would give you, 10.1.0.0 to 10.1.0.3. Now that's actually 4. So the minimum amount of addresses you can have on a network is 4, because remember you need your network address, which is the very first one. That can't be assigned to any devices. Then you need your broadcast address, which is the one that allows you to broadcast to all the available devices on the network. So when you take those out of it, you get 10.1.0.1 to 10.1.0.2. So then when these 2 IP addresses are assigned, the network is full, no one else can join it, so that makes a very secure network for that device. So just rub some of this off. And the last network that we're concerned with is the actual UL network, which is 193.1.0.0/16. So this network has 65,536 available addresses. UL doesn't have all of this network, but they have most of it. This is what's called a C-class network. It's the smallest full block of network addresses that you can buy. Originally, the way that it was done, now you can have, with the shortage of IPv4 addresses, you can break them up all the way down to, they're typically broken up into 256 blocks now to be leased off. So Skynet, interestingly enough, when we initially started, or close enough to when we started, had a C block that was 65,000-ish addresses. That got confiscated from us because they started confiscating them from organizations that weren't using all of them, so obviously we didn't need 65,000 addresses. That's the UL network. So, but UL doesn't have all of this, and also even if they did, they would split it up and you'd lose lots of addresses by the subnetting of it. So if you actually look at the UL network, which is 193.1.0.0/16, the Skynet public network is actually part of that, 193.1.99.64/256, because this goes all the way from 193.1.0.0.1 to 193. Make sure I get this right. .1.255.254. So we're actually included in that. So we're broken off. HENET has broken off a small subnet for us to use for our machines, and that's included in the UL allocation. So why do we need to know this? So I suppose one of the most important reasons why I put this on as one of the first topics was if you're doing any work on Skynet, it's important to know what network you're on for security reasons. So all of these different networks have different privileges in the firewall, so they look at where, say if you're on the UL network, we have rules in our firewall that may give you more access to the cluster than if you were outside the UL network. Or say if requests were coming in for the Skynet private network, that network is a lot more locked down than the public network that we have. Also, if you want to make VMs or anything like that, you need to kind of know what network you're going to put it on, what's a good spot for it, because wherever you put something or what network you're using, the firewall rules get affected based on what network you're using. The last thing we'll show you is how you would add a VM or a new machine onto the Skynet public network in Linux. So in Linux, there's a file called /etc//network/interfaces, and that's where a lot of the the networking information is set up for most distros. So how you would add a new VM to the public network, it's pretty much the same for the private. Addresses are different, but we'll walk through the public one first. So we have an address. So how you set up a static IP depends on what distro you're using, but this is generally how it's done in Linux. So you'd have a line saying what interface you were on and then static somewhere in it. So the address we're going to pick is 193.1.99.74. So that's actually the public IP address of the Skynet login box. So this would be the IP settings that you would use to connect that box out to the network. Then we have our net mask. So this net mask corresponds with the /26. So it's the subnet mask that lets the machine know how big the network it's on is and what IP addresses are available in the network as well. So the next one is actually the network address. 193.1.99.64. So this is the lowest IP address in the available in the network. So using the address information, the network information, and Subnet Mask, it now knows what network it's on, what IP addresses are available, and all that kind of stuff. We're also going to give it the broadcast address. 193.1.99.127. So Linux wants you to specify all of these different pieces of information, but you can actually work all of it out by just having this and this, but they like you to specify this as well. Well, you have to as part of the system, but you can work it all out based on these two. Next we have the gateway. So the gateway is what IP address this machine should route its traffic back to in order to get it out of the network. So what this IP address is, it's actually the IP address, the internal IP address of our firewall. So in our firewall, the connection comes in, it comes into the firewall, and the IP address of the outside and the inside is actually different. So this goes out to the internet. So the IP address here is 193.1.99. Just check this now. .72. And then before it goes out to our switch, the IP address of the other side is 193.1.99.125. So all the machines on Skynet route their traffic back here, and then it goes back through the firewall, and the firewall will drop anything that's not supposed to be sent out from the network through this interface, and that will go out to the ITD router. Yeah. So when the ITD router is routing traffic to us, they know to send it to this IP address, but when we're going the other way, we know to send it to this IP address. The next one is we need to tell the machine where its DNS servers are. So DNS servers, or domain name system name servers, are what the system uses to convert IP addresses into domain names or domain names into IP addresses. So all of the Skynet names like web.skynet.ie, mail.skynet.ie, skynet.ie, any of those services are all, their name records are all stored in these two DNS servers. We have two for redundancy. And the last thing we need to specify is DNS Search. And that is Skynet.ie. So what DNS Search does is on any of the machines on Skynet, you can look up, instead of having to go use the IP address or type, like say you wanted to get to Skynet, you wouldn't have to type in that IP address or type Skynet.ie or kit.skynet.ie. You could just type kit and it would know to search first for anything.skynet.ie. And it'll use that to find kit.skynet.ie, then it'll resolve the IP address. So it just makes it easier for us if we specify this. Yeah, so that's pretty much it for networking. There's one main switch in the Skynet network. It's a gigabit switch, so we have a gigabit connection back into the UL network. Then that comes in and it's split out to all the machines through one switch. And we also have a dedicated switch between Ultron and Jarvis, because Ultron is the NAS and Jarvis runs all the virtual machines, so all the disks for the virtual machines are stored on Ultron. So we need really quick access between them. So that's the other system. Those switches are smart managed switches, so they can be controlled through console connections on the kit management box, and I think also on Ultron. The reason they're not on the same box is because we only have one console port on each server. So what a console port is, it allows you to make a serial connection to another device, like a switch. So that's how we manage our switches. Yeah, so that's everything to do with networking within the Skynet cluster. So thanks for watching the networking topic of the admin training. I hope you found it useful. Thanks.